Welcome back. Welcome to 9th class physics world. Yeah, last previous class in laws of motion, Newton first law, Newton second law, Newton third law statements I told. Now in this class, what are the examples of Newton third law? Activity 7 in our textbook and activity 8 I will explain in this video. Now, what are the examples of Newton's third law and derivation of Newton's second law? What is the Newton's second law equation? F equal to ma. Yes. What is the F equal to ma? F means force, A means acceleration. So, force is directly proportional to acceleration. Now, I will explain Newton's third law, and that is Newton's third law based on some discuss examples. Some topics we will discuss in example wise. Okay, let us start. Okay, what is Newton's third law? Yes, already I told. Once again, every action there is an equal and opposite reaction. Every action there is an equal and opposite reactions. Every action there is an equal and opposite reactions. Yes. So prati action ki oka reaction untu untundi. This is Newton's third law basic principle. Yes. What are the examples of daily life in daily life? So it is very easy concept. One is gun, bullet gun. So bullet fired. Yes. That gun, from gun, the bullet is moving in forward direction. Yes. When this bullet is forward direction, yes, that trigger is on. A trigger no backward. Yanakilante appudu a bullet mundukel. So this is trigger action act. This is trigger pressing action. So in this gun fired, then bullet is moving forward direction. This is called action. This is called reaction. Gun. Take another example. What is that? Rocket. Actually, rocket moves in upward direction. This gas chamber in downward direction. So gas, it means fire in downward direction. This is action. It's supposed to apply downward direction. This is action. This action, there is equal and opposite reaction. So rocket moves in upward direction is a reaction. The gas in downward direction is a action. So this is called action. This is called reaction. So here it is equal magnitude, but direction is opposite. Forces are equal. Yanta force to iste ante force to paiki veltundi. So equal and opposite reactions. And third example is boat moving in water. Yes. మనం బోట్ మూవ్ చేస్తున్నప్పుడు ఒక బోట్ లో చిన్న పడవలో జస్ట్ ఒక స్టిక్ తీసుకుని ఇలా అంటారు. సో దిస్ ఈస్ బ్యాక్వర్డ్. సో దట్ బ్యాక్వర్డ్ ఇన్ వాటర్ బై హ్యాండ్, దట్ ఈస్ కాల్డ్ యాక్షన్. సో రియాక్షన్ మీన్స్ ద బోట్ ఈస్ ఫార్వర్డ్ మీడియం. The boat moving direction is called reaction. So by hand the applied to backward is called action. So here it is called action backward. So reaction means the boat is moving in water and forward medium. Yes, these three examples of daily life examples in Newton's third law. What are the example of in our textbook? Now we will enter into the basic on Newton third law, Newton first law, Newton second law. Chala cheppanu. Mari now derive the equation of న్యూటన్ సెకండ్ లా. యాక్చువల్లీ దిస్ కాన్సెప్ట్ నేను లాస్ట్ ప్రీవియస్ క్లాస్ లో నేను చెప్పాలి, బట్ నేను డెఫినేషన్ పరంగా మీకు ముందుకు వెళ్తున్నాను కాబట్టి న్యూటన్ థర్డ్ లా. ఇప్పుడు న్యూటన్ సెకండ్ లాకి వస్తున్నాను. డెరివేషన్ ఆఫ్ న్యూటన్ సెకండ్ లా. ఇట్ ఈస్ వెరీ ఇంపార్టెంట్ క్వశ్చన్. వాట్ ఈస్ ది స్టేట్మెంట్ ఆఫ్ న్యూటన్ సెకండ్ లా? What is the equation of Newton's second law? How to derive Newton's second law? Let us start. What is the derivation of Newton's second law? Let us start. What is the statement before? What is the statement? Yes, Newton second law. Yes, this Newton second law is very important. What is Newton's second law? Net force applied one object. This net force is directly proportional to the rate of change of momentum. The rate of change of momentum. Yes, it is called the statement of Newton's second law. Apply net force on one object. That net force is directly proportional to the rate of change of momentum. Yes, what is net force? Yeah, net force F is directly proportional to, it is the symbol, the rate means time, rate means divide the time, change means delta, momentum, it is the symbol of P. So already I told momentum is equal to, last previous class, mass into velocity. So P is equal to mv. Here please listen carefully. Net force is directly proportional to the rate of change of momentum. F is proportional to delta P by delta T. Yes, then F is directly proportional to is removing. In that place you put is equal to, proportional to this is equal to పెట్టినప్పుడు then ఖచ్చితంగా అక్కడ ఏముండాలండి, కాన్స్టెంట్ అనేది ఉండాలి. ఎస్, కాన్స్టెంట్ ఇంటూ డెల్టా. వాట్ ఈస్ P? Momentum. What is the formula of momentum? P is equal to mv. Then substitute mv by delta T. Okay students, then F is equal to, here constant is called K. Generally constant is denoted by symbol K. So constant K పెట్టేసారు. Next m front కి రండి, into delta V by delta T. m ఎదరికి వచ్చింది, ఇంకా మిగిలింది delta V by delta T. Now what is delta V by delta T? Here once observe carefully, V means velocity, T means time, it is nothing but rate. So the rate, delta means change, V means velocity. So the rate of change of velocity called acceleration. So the rate of change of velocity is called acceleration. So then finally rate means time, change means delta, velocity means V. So delta V by delta T means acceleration, that is equal to A. So this A substitute in this equation of F is equal to K into ma. Okay, delta V by delta T is a replacement of A. So దీని ప్లేస్ లో మనం A పెట్టడం జరిగింది. So m as it is, K as it is. So then F is equal to K into ma. So K into ma. K means constant, m means mass, and A means what is that? Acceleration. Okay students, here K is a proportionality constant. Put K is equal to 1. General గా మనం K is equal to 1 పెట్టుకుంటాం. Yes, Then finally F is equal to 1 unna lekanute kadandi, 1 into ma. Okay, then finally Newton's second law equation is F is equal to ma. What is F is equal to ma? Is nothing but force is directly proportional to acceleration. It is nothing but F is equal to ma. M means mass, it units kg. A means acceleration, it units what is that, meter per second square. Now I will write on the board one condition. 1 kg meter per second square is equal to Newton. Please listen carefully. 1 Newton is equal to 1 kg meter per second square. గుర్తుపెట్టుకోండి. ఇక్కడ చూడండి, F equal to K into ma. Here F is measured in Newton. గుర్తుపెట్టుకోండి. ఫోర్స్ కి యూనిట్స్ న్యూటన్ అండి, కాబట్టి F బదులు నేను n పెడుతున్నాను. ఎస్, K ఎన్ని ఉంటుంది. M అంటే మాస్ కి యూనిట్స్ kg. ఎస్, A అంటే యాక్సిలరేషన్. వాట్ ఆర్ ది యాక్సిలరేషన్ ఆఫ్ యూనిట్స్, మీటర్ పర్ సెకండ్ స్క్వేర్. నౌ M is equal to K into what is the kg, మీటర్ పర్ సెకండ్ స్క్వేర్. మనం న్యూటన్ అని సబ్స్టిట్యూట్ చేయొచ్చు. దిస్ న్యూటన్ లో క్యాన్సిల్ 1 టైం. దెన్ ఫైనల్లీ K is equal to 1. ఇదే కదా మనం ఇక్కడ సబ్స్టిట్యూట్ చేసాం. ఎస్, అంటే అకార్డింగ్ టు యూనిట్స్ పరంగా మనం అలా ప్రపోర్షనాలిటీ కాన్స్టెంట్ అంటాం. అందుకే K వాల్యూ నేను 1 పెట్టేసుకున్నాను. So then finally F is equal to ma. Force is directly proportional to acceleration. The rate of change of momentum is directly proportional to net force. It is the statement and derivation of Newton's second law. Newton's third law. Newton's third law of motion means what are the example of what are the activity of Newton's third law in our textbook activity 7. Now we will discuss about Newton's third law in this part. Means apart from this, what is the activity? Balloon rocket. Yeah, it is very important. It is very funny logic, means funny activity. Yeah, ready, start. Inflate a balloon. Yes, inflate a balloon. Inflate means this one. Vodandi. Yes, and press its neck, this neck, with fingers to prevent air escaping from it. బయటికి వెళ్ళకుండా ప్రెస్ చేయండి ఫింగర్స్ తో. అండ్ నెక్స్ట్, పాస్ ఏ థ్రెడ్ త్రూ ఏ స్ట్రా. టేక్ 1 straw through the thread and tape the balloon on the straw. సో ఈ స్ట్రా కి ఈ బెలూన్ ని టేప్ చేసేయండి. ఎస్, స్టిక్ చేయండి. Now hold one end of the thread, yes, here, and ask your friend to hold the other end of the thread. Now you hold one end of the straw, your friend hold other end of the straw. Now what is the, remove your hands from balloon neck. Previous you press its neck with your finger. Now remove your fingers, yes, from balloon neck. Then what happens? Immediately that balloon fly off. Yes, means straw and balloon automatically moves back opposite to neck of the balloon. Opposite to neck of the balloon means itunte adi ala egiripotundi. Means here pressing its neck with your fingers, then remove your fingers on the neck of the balloon. Immediately the balloon fly off to opposite direction. So here straw means and balloon automatically move back opposite to neck of the balloon. Yes, correct. What we conclude this topic? What do you observe this topic? What is information of this topic? Yes, this topic, this explain about this activity, Newton's third law of motion. Yes, there is every action means there is an equal and opposite reaction. Every object there is an equal and opposite reactions. So the air from neck of the balloon, yes, what we conclude? Exert a force on surrounding atmosphere. On surrounding atmosphere, the air from neck of the balloon, yes. Now, and surrounding atmosphere pushes this balloon with equal force in opposite direction. Here, the air from neck of the balloon applied force on surrounding atmosphere, it is called action. What is that? Action. So here, the surrounding air pushes this balloon with opposite direction, it is called reaction. Okay? For every reaction, there is an equal and opposite reaction. It is explained about Newton's third law. This balloon push its neck with our fingers. Then, after some time, you remove fingers on the neck of the balloon. Immediately, the straw and balloon automatically equal magnitude, equal force తోటి opposite directions లో వెళ్ళిపోతుంది. సో అక్కడ ఆపోజిట్ డైరెక్షన్ లో అప్లై చేసే సరౌండింగ్ యొక్క ఎయిర్ ఆ బెలూన్ పుష్ చేసింది. దట్ ఈస్ ద రియాక్షన్. నువ్వు ఎప్పుడైతే ఫింగర్స్ ఆ నెక్ ఆఫ్ ది బెలూన్ దగ్గర వదిలేసేవో వెంటనే సరౌండింగ్ అట్మాస్ఫియర్ ఏం చేసింది? ఒక ఫోర్స్ అప్లై చేసింది. దట్ ఈస్ కాల్డ్ యాక్షన్, రియాక్షన్. ఫర్ ఎవ్రీ రియాక్షన్ దేర్ ఈస్ అన్ ఈక్వల్ అండ్ ఆపోజిట్ రియాక్షన్. So it is explained about Newton's third law of motion. Another example of Newton's third law of motion. So this example also based on Newton's third law of motion. For every action there is an equal and opposite reaction. Yes, let us start. When a fish swims in water, yeah, do you know fish? Yeah, this fish swims in water. Yeah, the fish pushes back the water. ఎప్పుడు కూడా వాటర్ లో వెళుతున్నటువంటి ఫిష్ వాటర్ ని వెనక్కి పుష్ చేస్తుంది. ఎస్, దట్ ఈస్ కాల్డ్ యాక్షన్. అండ్ ఆటోమేటికల్లీ విత్ ది సేమ్ ఫోర్స్ వాటర్ పుషెస్ ఫిష్. దిస్ ఈస్ కాల్డ్ రియాక్షన్. విత్ ఈక్వల్ ఫోర్స్, ఎగ్జాక్ట్లీ, but in opposite direction. First case, fish swims in water, pushes back the water. This is action. Then automatically, in that case, water pushes the fish. That is the reaction. It is equal force but in opposite direction. It is dull example of third law of motion. So here, the force exerted by water means applied. The force applied by water makes fish to move forward. So here the force applied, it means exerted by water. Water apply చేయడం వలన fish ఏమైంది? To move forward. So this is action, this is reaction. For every reaction, there is an equal and opposite reaction. It is the another example of Newton's third law of motion. Okay, now I will take another example of Newton's third law. Yes, what is that? Let us start. If a fly collides, fly means insect. If a fly collides with windshield of fast moving bus, yes. Windshield means window or mirror, something like that. A fast moving bus. Is the impact force same for the fly and bus? Yes. So fly is moving this and bus is moving this direction. So opposite direction but equal force. Yes. So the fly collided with the windshield of fast moving bus. The fly applied force on the bus. The bus applied force on the fly. Both are same. But equal magnitude but in opposite direction. Yes. Both bus and insect same exert a force and same change in their momentum. Yes, exactly correct. Same force applied and same change in momentum. Change in momentum. What is the momentum? P. What is the formula momentum? mv. So mass into velocity is same. Force is also same. For every reaction, there is an equal and opposite reaction. This fly collide with the windshield of fast moving bus. Same force applied on this case, but direction is opposite. It is the explain about Newton's third law. Up to here, Newton's third law of motion example is completed. Now, what you understand once recall that formula, unit, symbols, that is vector or scalar. Yes, let us start. Okay, here physical quantity means mass. So mass is symbol m. Mass formula nothing. In mass in CGS unit grams. Yes. In mass is kilogram means SI unit kilogram. Yes. And this is mass is a scalar. What is scalar? Previous class I told. A physical quantity has both magnitude and direction is called vector. Only magnitude but no direction is called scalar. But no direction is called scalar. Yes, mass has not particular direction. That's why mass is a scalar. And next one, momentum. Already told. Momentum is denoted by symbol P. This P symbol, the formula is P is equal to mv. So what is m? Mass. What is v? Velocity. So mass into velocity, it is the formula of momentum. So what are the units in CGS system? Mass is measured in gram, but velocity is measured in CGS centimeter per second. Total gram centimeter per second in CGS. And what are the units in SI units? kg meter per second. Because mass is measured in kg, but velocity is measured in meter per second. Then finally kg meter per second. Yes, it is a vector because momentum, mass into velocity, it has both magnitude and direction. That's why momentum is a vector. And next one, you go coming to the topic force. Yeah, applied force. Force is called push or pull. Yes, it is the general basic of definition. Push or pull. Yeah, force. Force is denoted by symbol F. According to Newton's third law, already I told previous, F is equal to delta P by delta T. What is the P? Momentum. What is the delta? Change. So rate of change of momentum is called rate of change of momentum. Yeah, is equal to force. For F equal to delta P by delta T. Here F equal to ma. Already I told I derived this equation. Then finally force is equal to F equal to ma. So here in CGS system, force is measured in time. Please be careful. Please remember. And this force also measured in SI unit to Newton. So Newton is denoted by symbol capital N. Yes. And scalar, vector. Chuskunte force is a vector. So what is vector? Both magnitude and direction is called vector. So force is a vector quantity. It is the unit of formula. And last one is impulse. Yeah, already I told previous, impulse means force into time. Force into time. The cricket field, in cricket bowler catch that ball, the drag on our hand. That is impulse. So force into time, it is denoted by symbol J. Impulse is generally denoted by symbol J. So here in CGS system, dyne second, because force is measured in dyne, time is second. So force is measured in SI system Newton and time is measured in second. Then finally, it is a vector quantity. So total, it is the basic principle, means the basic formula and units in the laws of motion. Okay students? Okay, up to here, formula, definitions, units, symbols, scalar quantity, vector quantity, Newton's third law of motion, Newton's second law derivation, F is equal to ma, daily life example of Newton's third law, activity 7 in our textbook. ఇలా చాలా నేర్చుకున్నాం. ఓకే, మరికొన్ని కొత్త కాన్సెప్ట్ తో మరి నెక్స్ట్ మళ్ళీ మీ ముందుకుంటాను. అంతవరకు స్టే హోమ్, స్టే హెల్తీ, బాయ్.
The only question you need to ask yourself while studying the third law is, what happens when two objects interact with each other? What happens when you place an object on the table? The object exerts a force on the table and the subject exerts an upward force on the object. There are two forces that result from this interaction: a force on the table and a force on the object. The magnitudes of the two forces are the same, but the directions are opposite. These forces are called as action and reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. What we saw here is nothing but a display of the Newton's third law of motion. Every action has an equal and opposite reaction. That's how simple the third law is. Every action has an equal and opposite reaction. It means that when two objects interact, there is a force on each object. The magnitude of force on the first object equals the magnitude of force on the second one. And what about the direction? The direction of force on the first object is opposite to the direction of force on the second one. Let's talk about more examples. While a frog is swimming, it pushes the water back and the water pushes its body forward. Now let me ask you a question. Say a bird is flying upwards. Will the Newton's third law apply here? Sometimes the third law is not so obvious. You'd probably say that the bird is the only object here and there's no second object. But that's not correct. The wings of the bird push the air downwards and the air pushes the bird upwards. Action and reaction forces make it possible for birds to fly. We take one last example to understand something very interesting about the third law. What happens when a gun is fired? You're right, it exerts a forward force on the bullet. And the bullet exerts an equal and opposite reaction force on the gun. And this exists in recoil of the gun. A perfect example of Newton's third law. But hold on. If the force exerted by the gun on the bullet is the same as the force exerted by the bullet on the gun, then why doesn't the gun recoil with the same acceleration as the bullet? The gun recoils, yes, but it doesn't recoil at the same acceleration as the bullet, right? Same magnitude of forces, but different accelerations. Why do you think this happens? Okay, so if your concept of the second law of motion was clear, you wouldn't really be surprised with this. The second law of motion says that the force is the product of the object's mass and acceleration. Or the acceleration of the object is equal to the force over its mass. What does this tell us? Yes, if the mass is more, then the acceleration will be less. In this example, the mass of the gun is much more than that of the bullet. Hence, the acceleration of the rifle is lesser than that of the bullet. If you're in a boat and step out of it onto the land, there are two forces involved. You pushing the boat behind and the boat pushing you forward. And that's why you see the boat go behind when you go forward. Now let's say a sailor jumps off a huge ship. The sailor does apply a force on the ship and the ship also applies a force on the sailor. But do you think the ship will accelerate as much as the sailor? Not really. And I think you know why.